For centuries, the idea that empty space is an absolute nothingness has been, surprisingly, a recent anomaly in physics. For millennia, human thought intuitively rejected the concept of a true vacuum, suggesting space must possess some physical substance. What changed, and how is modern cosmology revisiting this ancient intuition?
Mia, that historical rejection of a true vacuum, what the ancients called horror vacui, is central to our model. Think of Aristotle's quintessence, a crystalline fluid filling the cosmos for celestial motion, or Descartes' plenum, where mechanical vortices explained gravity, not some magical force. Even in the 19th century, the luminiferous aether was theorized as an elastic medium for light waves, much like air for sound. Our model, cyclic quantum cosmology, takes this ancient intuition to its logical conclusion. We propose that strings and their grid aren't abstract ideas, they are the modern quantum geometric mechanical version of that ancient aether. Space, for us, has a tangible structure, its own physical density, and its own elasticity. We don't just move in space, we move through the substance of space itself.
That's a profound shift in perspective. If space is a substance, then what defines its most fundamental component, the string? You've mentioned a redefinition of the string beyond conventional theory.
Exactly. We define the string as a geometric mechanical hinge or anchor. It doesn't entirely belong to our four-dimensional space-time. Instead, it roots itself in the higher dimensions of what we call the bulk. What we perceive and isolate in our universe is just its projection, its anchoring point on our fabric.
So the string isn't fully contained within our observable universe. It's more like a connection point.
Precisely, and it's crucial to understand that in this model, the brain is pure energy. The mechanical memory of returning to equilibrium is held solely by the brain. However, the connection between strings is purely a mechanical act. The string acts as an invisible interface, translating the multidimensional laws of the bulk into everything we perceive.
You call this dynamic spin, tension, and connection. Can you elaborate on these elements?
Certainly. First, tension and memory. When a string is torn from the large sheets of the bulk during a primordial impact, it undergoes elastic deformation, much like a stretched spring. It possesses an intrinsic tension, a mechanical and geometric tendency to return to its original length. This tension also conveys the brain energy it carries. Then there's spin, which isn't just an abstract quantum number. In our model, it's the physical oscillation and three-dimensional torsion of limbs, or geometric extensions of the string that vibrate in the extra dimensions of the bulk, up to 11 dimensions. Each string has a specific vibratory signature from its original impact.
And connection?
That's when two strings cross in the grid, their extra-dimensional limbs interact. It's important to remember that a string also connects directly with brains. Now, a key point, unlike classical interpretations, this initial interlocking of strings doesn't create stable matter. Strings solely create the space within which everything moves. Heavy matter isn't formed at this stage.
So matter arises later. This brings us to what you call the mechanics of the break and crystals of space. How does space itself come into being through this process?
In the multi-dimensional bulk, the kinematic impact between primordial brains destroys their geometric continuity. From this break, volumetric fragments endowed with torsion are born. These pieces of empty space crystal are catapulted into our subsystem, initially carrying brains, energy, in a one-to-one equilibrium. Once movement and expansion begin, this system loses its original equilibrium. Strings then undergo continuous deformations and energetic exchanges.
And the memory you mentioned, is that where gravity originates?
Yes, but it's crucial to specify. Only the brains carry memory as energy. Strings are just transport vectors, geometric structures totally devoid of their own memory. The perennial tendency of these fragments to restore the original shape of the large sheet, nullifying the deformation, is the mechanical memory carried by the brains. This microscopic memory, this tendency to return to the original geometric equilibrium, is the physical origin of the force we call gravity.
That's a very different picture of gravity. You also draw a parallel to computer science, describing the universe as a cosmic binary code of strings and brains.
The complexity of the universe can indeed be reduced to a fundamental binary combination between just two entities, strings and branes, much like complex software is written in zeros and ones. State 0 represents an empty string, geometrically neutral space, the invisible elastic grid devoid of mass or energy. It's the physical support, the channel for information, the silence that allows sound to exist.
State 1, then, would be the active state.
Precisely. State 1 is a string hosting a brane carrying energy. When the brane comes aboard, the bit turns on, and active information is born, a specific vibration we measure as mass, electric charge, wave, or a photon. If you imagine an evolutionary line of charge, an empty string is the geometric 0. As more branes climb onto it, perturbations generate waves. This accumulation reaches a saturation level, the photon.
So, a photon is a string at maximum brane saturation. What happens if you add even more energy?
If even an infinitesimal fraction of extra energy, another brane, is introduced at the photon's saturation level, the system collapses, crumples, and transforms into what we interpret as heavy matter. Continuing to accumulate charges in the lattice leads to the heavy elementary particle, then to heavy elements, which represent the maximum stable scale. Macroscopically, what we see is billions of these strings carrying billions of branes, a complex architecture.
So physics is really just the continuous combination of these two states. Where does cosmic inflation, the rapid expansion of the early universe, fit into this mechanical framework?
Our model offers a mechanical explanation for inflation. Initially, the universe from the first kinematic impact reached a state of relative equilibrium, a peaceful primordial soup of waves traveling linearly. Then a second, massive kinematic impact occurs in the bulk. An immense shock wave, loaded with new strings and branes with different vibrations and spins, invades the area of the first universe.
And this clash causes the inflation.
Yes, when these two enormous waves meet, the strings from both Big Bangs find themselves partially compatible. Their spins and frequencies begin to hook and interlock at frantic rates within the lattice. This mass engagement triggers a chain elastic reaction of titanic proportions. The violent union instantly releases accumulated kinetic energy, destabilizing the first Big Bang's grid. The fabric of space itself is stretched and elongated outward instantaneously. This sudden, immense increase in geometric volume is exactly what traditional astrophysics observes and defines as cosmic inflation. It's not a magical expansion, but the mechanical response of the elastic lattice accommodating the intrusion of the second wave of strings.
That's a powerful explanation. After this violent push, how does the universe then differentiate into ordinary matter, and dark energy? There must be an evolutionary sieve at play.
After inflation, the system cools and settles. The infinite possibilities of vibration and spin from the two Big Bangs pass through a rigorous mechanical selection, what we call the sieve, generating three precise destinies. Ordinary matter forms when strings from both impacts, with compatible spins, complete their engagement, accumulating and structuring reactive branes. This leads to the evolution towards saturated waves, then to photons and heavy matter, like atoms and light.
And dark energy?
Dark energy represents the branes from the second impact that didn't find any string with a compatible spin to latch onto. Lacking a geometric body, they float free in the grid's interstices, behaving like an incompressible fluid. They exert a constant pressure, forcing the three-dimensional grid to continuously expand. We've previously discussed how central galactic black holes assist this by continuously releasing new virgin space strings.
And what about dark matter?
Dark matter consists of strings connected with branes that lack the requirements to interact with the new energetic flows of the second impact. They remain excluded from the main dynamic, an invisible residual broth. They have a geometric mechanical presence in the lattice that doesn't interact with the light spectrum, but exerts gravitational attraction through the intrinsic elastic memory of their own branes.
This model also tackles the
Tolman challenge.
The paradox of accumulating entropy in cyclic cosmologies.
Yes, we solve it mechanically. Black holes are the system's recyclers. They absorb complex, worn-out matter, strings charged and saturated with entropy, break their bonds, separate the brains, and release virgin strings back into the cosmos. These are stripped of all previous information, essentially pure spatial grid at state zero. This cleaning mechanism resets local entropy each cycle, allowing the system to regenerate indefinitely without thermodynamic degradation.
That's a complete cycle. To ground this in our everyday experience, you use the paradox of the two coffee beans to explain gravity on a macroscopic scale.
Imagine two coffee beans in the vacuum of deep space, isolated. After some time, they will attract each other until they touch. This isn't magic. A single coffee bean doesn't generate force out of nowhere. It's composed of billions of aggregated strings and brains. Remembering that brains carry the elastic memory of returning to equilibrium, each brain loaded onto the strings inside the bean exerts an infinitesimal tension on the surrounding fabric of space.
So the sum of those tiny tensions becomes a macroscopic force.
Exactly. When billions of these microtensions add up inside the bean, the combined elastic effect becomes a measurable macroscopic force capable of moving the two bodies together. Gravity isn't action at a distance, it's the macroscopic resultant of infinitesimal mechanical tensions. We believe this model can be tested. Physicists could look for anomalies at microscopic scales, the Planck scale, or over enormous galactic distances. At these extremes, the discrete nature of the spatial grid should manifest tiny fluctuations, infinitesimal elastic deviations not predicted by general relativity. This is a point ready for mathematical modeling and testing.
This sounds quite similar to M theory, with its extra dimensions and brains, but you emphasize crucial differences.
There are points of contact. Both models acknowledge 11 extra dimensions, both use strings and brains, and both see vibration as the origin of elementary particles. But the crucial differences lie in the approach. M theory is an abstract mathematical model based on supersymmetry. Our model is rigorously mechanical and geometric, reasoning through impacts, elastic tensions, physical fragmentations, and direct couplings. Also, in M theory, strings vibrate in a landscape of infinite universes without a true evolutionary direction. In our model, the properties of strings, their spin and compatibility, are the direct historical result of two specific, successive kinematic impacts, the first and second Big Bangs. There's an evolutionary selection process that separates ordinary matter from dark matter. And finally, in conventional physics and string theory, space-time is often the field where strings move. Here, space itself is made of strings. There's no empty space containing strings. It's the empty strings elastically connected that weave the grid we call space.
This has been a fascinating journey into rethinking the very fabric of reality, from ancient intuitions to a dynamic, mechanical cosmos. Next time, we'll delve deeper into how this model explains phenomena like the double slit experiment and the photon's dual nature. If you found this exploration thought-provoking, consider sharing it with someone curious about the universe's mechanics.